Welcome back. In the last session we started student workbook problems and we solved 3 problems, right? Now let's solve problem number 4. Assuming VCE sat is equal to 0.2 volt and beta is equal to 50, the minimum base current required to drive the transistor in the figure to saturation is. What is given? VCE sat. .2 volt, beta 50, and is asking the minimum base current required to drive the transistor to saturation. IB minimum for saturation. That is what is the problem. And the circuit is option A 56 microampere, option B 140 microampere, option C 60 microampere, option D 3 microampere. How will you solve? I think we discussed this already, right? Now what is asking is, we know that I gave you already, this is what your IB and this is what your IC. When the transistor is in saturation, your IC will track to IRB, but once the transistor is entering into, what do you call? This is what your active region and this is what is your saturation, which we have seen already. Right? Now this is what is your beta into IB. This is your beta into IB and this is what is your IC sat. Your IC sat will be less than beta into IB. Now for the saturation, to drive the transistor into saturation, what is the minimum IB? This is what is your IB minimum. This is what is your IB minimum. When the transistor is entering into saturation, starting of the saturation, whatever IB you have, therefore when you increase IB more than this, the transistor will be for sure in saturation. That is what is asking, right? Therefore now tell me, to be in saturation and the minimum value of IB to be in saturation is IB minimum, then exactly at this point you can say IC is equal to IB, right? Therefore what is that? For IB minimum, we know that your IC sat is less than or equal to beta into IB. Therefore exactly at saturation, right? Therefore IB minimum will be the minimum IB where it is equal is nothing but your IC sat divided by beta. Okay. Therefore now tell me, VCE sat is given, beta is given, therefore you know the VCE saturation, when the transistor is in saturation, your VCE sat is 0.2, then can't you find IC sat? Then what is this? This is nothing but your IC sat. Then this is nothing but IB minimum. Whatever you have is this one only, IB minimum. I am just correcting it. Therefore now this is what is your equation 1. To find IC sat. To find IC sat using output KVL. Now write output KVL. What is output KVL? This voltage is equal to this voltage plus this voltage. Therefore P is equal to the drop across 1K, which is nothing but IC sat into 1K plus VCE sat plus VCE sat. Therefore what is IC sat? Therefore IC sat is equal to 3 minus VCE sat divided by 1k, which is nothing but 3 minus 0.2 divided by 1k, which is 2.8 milliampere. This is what your IC sat. Then from equation 1 implies, what is your IB minimum? IB minimum is equal to IC sat 2.8 milliampere divided by, what is your beta? Beta is 50. Therefore, what is this? 1 by 50 is nothing but 0.02. 0.02 into 2.8 milli is nothing but 20 milli. Milli will become, therefore 20 into 2.8, which is nothing but 56 microampere. If your IB, whatever IB you are passing at the input, if you try to cross your IB more than or equal to 56 microampere, then your transistor will enter into saturation. If your IB, input current IB is less than 56 microampere, your transistor will be in active region. Therefore, who is driving the transistor or who is biasing your transistor? Here, the IB. Whatever biasing you have at the input with respect to 1K and all, this is what is for 56 microampere, that is the edge of active region as well as saturation region. Okay, done. What is the answer? 56 microampere. That is what is the minimum base current. Minimum base current for your saturation. This is the minimum base current for saturation region. Okay, take it. Then you will solve problem number 5. Done. Now let's see problem number 5. Assuming that the beta of the transistor is extremely large, and VBE is equal to 0.7. Then IC and VCE in the circuit shown in figure. Problem number 5. Beta is very large. And VBE is 0.7. Is asking for what is VCE comma IC, operating point. Capital VCE, capital IC. That what does it mean? This is for DC analysis. The circuit is okay. Now tell me what is the circuit which we had seen already, BJT DC analysis. This is nothing but a self bias circuit, right? Then can I write into, now what is our aim? Our aim is to calculate operating point VCE comma IC. That we can find using KVL equations. Okay. Now therefore tell me, can I write into equivalently apply Thevenin's theorem for this? Then you will get V Thevenin R Thevenin. This is what is your R Thevenin, and this is your V Thevenin, and this is what is your circuit. This is 5 volt, this is 2.2k, 300 ohm, and this is what your IC and VCE. Okay, and the beta is very large. You know what is the meaning of beta is very large? When I say beta is very large, what is your IE? IE is nothing but IC plus IB. Then can I write IB as IC by beta? Because IC is equal to beta into IB plus 1 plus beta. I am neglecting the reverse saturation current part. Therefore IC is equal to beta into IB. Therefore if beta is very large, it is almost 0. Indirectly saying that you neglect IB with respect to IC. Don't say, never say IB is 0. IB is not 0. IB can be neglected with respect to IC. Wherever you have IB to IC, you can neglect IB with respect to IC. Right? That doesn't mean that IB is 0. Neglecting IB with respect to IC. Fine? Therefore your IE will be equal to IC. Therefore whatever you have, let us say this is also your IE is close to your IC. That is the meaning of, and then IB is close to 0 when you have a loop. Therefore I'm neglecting the drop across R Thevenin. No need to calculate, because whatever IB is nothing but IB into R Thevenin plus IE into or IC into 300. Therefore you can neglect the drop across R Thevenin. Fine? Whatever it may be. Now what is V Thevenin? V Thevenin is equal to 1k divided by 4k plus 1k, which is 5k into 5 volt. Then it is nothing but 1 volt. Therefore what is V Thevenin? V Thevenin is 1 volt. R Thevenin is 4k in parallel to 1k. 4 into 1 divided by 5, 4 by 5, but it is not required. Therefore now let's write input KVL. Input KVL. If you write input KVL, what is that? V Thevenin is equal to, this is what your IB, right? IB into R Thevenin, IB into R Thevenin plus VBE plus VBE plus the drop across, therefore which is nothing but IC into 300. Therefore can I neglect this part with respect to IC, because IB can be neglected. This is close to 0 because beta is very large. Your beta is very large. Then what is our IC? Therefore IC is equal to VThevenin minus VBE divided by 300. Therefore, what is VThevenin? 1 minus 0.7 divided by 300, which is 0.3 divided by 0.3 K, which is 1 milliampere. Now output KVL to find VCE. Output KVL. This is your IC. Now output KVL. When you write output KVL, VCC is equal to IC into 2.2K plus VCE plus IC into 300. Therefore, what is VCE? Therefore, VCE is equal to VCC minus IC into 2.2K, means 2.5K, right? That's it. Therefore, what is your VCE? Your VCE is equal to VCC 5 volt minus IC is already calculated 1 milli into 2.5K, K milli, then it is 2.5 volt. Then what is your VCE? VCE is 2.5 volt. Therefore, IC is 1 milliampere and the VCE is 2.5. Therefore, what is the answer from the options? Answer is C. Take it. I'll give you 1 minute time. Try to complete. Try to solve on your own once you know the procedure. Then we'll solve problem number 6. Done, right? Write down problem number 6. This is straightforward. The cascade amplifier. The cascade amplifier is a multi-stage configuration of CCCB, CECB, CBCC, CECC. Remember, answer is B. I already told you. Common emitter configuration is a common base configuration. That is what is called as cascade amplifier to improve voltage gain without affecting unity gain bandwidth. Okay, write down problem number 7. This is done. Now problem number 7. For NPN transistor connected as shown in figure, VBE is equal to 0.7 volt. VBE is equal to 0.7 volt. Given that reverse saturation current of the junction at room temperature, reverse saturation current of the junction, which is nothing but your IC naught, is equal to 10 to the power of minus 13 ampere at temperature is equal to 300 Kelvin. Actual reverse saturation current changes with respect to temperature, but the value is given at room temperature. Now, what is your emitter current? Okay, circuit is this is what is our VBE. If you observe clearly, this is nothing but NPN transistor. Okay, option A is asking for IE. Option A 30 milliampere. Option B 39 milliampere. Option C 49 milliampere. Option D 20 milliampere. Okay, listen. Actually, if you observe clearly, this is nothing but this is your collector. This is collector, base, emitter. When base and collector are shorted, whatever PN junction diode you have here, this is nothing but collector junction, right? This is your collector junction, right? Now, what is voltage across base to collector? A PN junction diode and then short circuit across it. It is nothing but what? PN junction diode voltage is 0. Therefore, it doesn't have anything. But the collector is nothing but your base. Therefore, base to emitter. This is nothing but a PN junction diode. This is another PN junction diode. This is nothing but your emitter junction. Right? Therefore, this is what people call it as diode connected transistor. Why? Because of the connection between base to collector, now it is nothing but collector and base. Both are same. It's like P to N junction. Therefore, it is nothing but PN junction diode. Therefore, people say that this is nothing but a PN junction diode. The BJT is converted into a PN junction diode. Which PN junction diode? Emitter junction. Whatever emitter junction you have, that is what is your PN junction diode. See, if you want PN junction diode from BJT process, right? Then just short collector and base, you will get PN junction diode. No need to have special fabrication steps to have PN junction diode. Just have BJT along with other transistors parallelly, short base and collector, and then take one terminal and then take another terminal, which is nothing but your collector, emitter, that is nothing but your PN junction diode. Okay? This is what is called diode connected BJT or diode connected transistor. Therefore, is asking, what is VBE? This is what your VBE, voltage across the diode. This is nothing but your 0.7 and asking for the current, right? IC or IE, both are same only. Therefore, asking for the current IE. You can calculate, right, what is voltage across the PN junction diode. We know that I is equal to I naught into e to the power of V by eta Vt minus 1. Right? Then if nothing is given, assume, remember, if nothing is given, you can take eta is equal to 1 until unless it is specified. Strictly speaking, it is 1.3 to 2. Olden days, eta value is 2 for silicon. Now that depends on process, right? 1.3 to 1.6, whatever it may be. Nothing is given. For the simplification purpose, we can take it as eta 1. See, this is what is the assumption which we are going to take for complete subject. If nothing is given, you can take eta is equal to 1. Okay, that's fine. Therefore, what is this? Therefore, IE is nothing but what? IE is equal to your I naught into e to the power of what is V? 0.7. At room temperature, what is Vt? 26 millivolt minus 1. I think you can neglect 1. Then if you solve this, what is I naught? 10 to the power of minus 13 into e to the power of 0.7 divided by 26 milli minus 1. If you solve using calculator, scientific calculator, what is that? 0.7 is nothing but 700 milli by milli. Milli will be cancelled. 700 divided by 26. E to the power of 700 by 26. If you solve, you will get it. Okay. Then you will get close to 49 milliampere. Okay, therefore answer is C. Take it. Using calculator, if you solve, you'll get it. It is simply PN junction diode problem, but we should understand that why it is PN junction diode. Okay. Do not have any confusion. This is your IE, which is nothing but series. In series, current is constant. Done. Write down problem number 8. In an ideal differential amplifier shown in figure, a large value of Re right? Large value of Re. Now, tell me, this is what your differential amplifier. We had seen this already, right? Then we had seen two things: common mode gain and differential gain, right? This is what your transistor 1 and transistor 2. Tell me, what is your common mode gain? What do you mean by common mode gain? When V1 is equal to V2, when you are applying the signal which is common for both the inputs, which is nothing but V1 plus V2 by 2, or V1 is equal to V2, if you say short both of them, you change this voltage. I don't want to see any change in my output voltage. This is what your, let us say, V01 and this is your V02. I don't want to see any change in V01 or V02. If you short both of them, they will vary, right? Therefore, your common mode gain is nothing but what is change in V01 with respect to change in common mode voltage, or change in V02 with respect to common mode voltage change, means V1 is equal to V2 and common mode, okay? Change in common mode voltage. Ideally we want 0. 0, this is what is ideal value. Okay, but practically if you calculate, what is that? Practically this is nothing but for this circuit having RE, if this is having current source, definitely that is 0. That will not agree to see the change here, therefore it will reject completely, the common mode voltage will be rejected. But here, because it is having a resistor, practical current source, we calculated, we got magnitude only RC divided by 2RE. This is what is your common mode gain. Okay, now number 2, what is differential gain? Definition: change in V0 to your output voltage divided by Vd. What is V0? V01 difference to V02 divided by V1 difference to V2, which we already got, you remember. This is nothing but your V01 divided by V1 or V02 divided by V2, your single amplifier voltage gain. Your differential gain of your differential amplifier is nothing but your single-ended common emitter amplifier voltage gain. Okay, and that we got this as magnitude only HFE into your load RC divided by HIE. It is independent of, therefore this is not a function of your RE, irrespective of RE, but here this is function of RE. Therefore now tell me, if you increase RE, what will happen? If you increase your RE, your common mode gain decreases. But if you increase your RE, it is independent. Therefore this is independent of RE. Therefore what is the answer? Your common mode gain decreases, your differential gain is not affected. Therefore which is satisfying the options? Option D. Answer is D. Take it. Next we will solve problem number 9. Done? Write down problem number 9. The circuit using a BJT with beta is equal to 50 and VB is equal to 0.7. Beta is equal to 50 and VBE is equal to 0.7. The base current and the collector voltage. Therefore, what is your IB and VC? This is what is given. Circuit is, tell me, is it DC analysis or AC analysis problem? This is DC analysis problem. If it is DC, you take only DC circuit. Therefore, what is DC circuit? The DC circuit is, directly I am taking from the circuit. Wherever the capacitor is there, you take it out. Therefore, This is what is VC. What is VC and IB? What is IB? That is the problem. Beta is given, right? Yes. Now, remember, if the problem is related to DC analysis, just KVL equations. Okay. Now, can you write input KVL first of all? Therefore, tell me, this is nothing but your IC, right? And what is this? This is your IE. What is IE? IE is equal to IC plus IB. What is IC? Beta into IB. If you take beta common, 1 plus beta into IB. This is what it is. Okay. Now, write down input KVL. Input KVL. If you write input KVL, 20 is equal to 430K into IB. 430K into IB plus VBE plus 1 plus beta. What is 1 plus beta? Beta is given already, right? Therefore, 1 plus beta into IB into 1 kilo ohm. Therefore, if you substitute, therefore what is this? Therefore, 20 is equal to 430K into IB. VBE is 0.7. 1 plus beta 51. Therefore, this is 51K into IB. Now, what is your IB? Therefore, your IB is equal to 20 minus 0.7 divided by 430, right? 481. Is it 481? 430 plus 51. Yeah, 481 kilo. Therefore, this is nothing but 19.3 divided by 481. This is nothing but milliampere. The K will become milli. Therefore, you need to calculate what is 19.3 divided by 481 approximately. Can I take 481 as 500? Then if I take it as 500, then if I take 19.3 as 20, 20 divided by 500, 0.05, therefore 20 by 5. You'll get it, right? Around 40, approximately 40. If you solve, approximately 40, but if you see the answers, 43, 40, 45, 50, all are close to 40. Don't do any approximation. Calculate exactly. If you calculate exactly, you will get it 40 point something. Therefore, you will get close to 40 microampere. Okay. Then apply output KVL. Therefore, what is output KVL? 20 is equal to the drop across 2K. IC into 2K plus VC. That's it. Because it's asking only voltage at collector, not VCE. Then you stop it. No need to go VCE plus something because it's asking only voltage at collector. Then what is your VC? VC is equal to 20 minus IC into 2K. What is IC? 20 minus beta into IB. What is beta? 50. IB 40. 50 into 40 micro into 2K. 50 into 40. 2000 micro. 2 milli. K milli. 4. Therefore, this is 16 volt. Therefore, what is your VC? VC is 16 volt and your IB is approximately 40 microampere. Therefore, what is the answer? 40 micro and then 16 volt. Answer is B. Answer is B. Take it. I think the session is almost done. We'll continue in the next session. By the time you try to solve on your own, if you don't get the answer, then only look for the solution. Okay. Thank you.